Now let's solve some equations that involve roots. Now the big idea for solving equations with roots is to use powers, because roots and powers are inverse operations. So if we start with an odd root, like a cube root or a fifth root, then we're going to want to use an exponent of 3 or 5. And if we have even roots, then like a 2 or a 4 or 6, then we're going to use exponents like 2 or 4 or 6. One thing you do have to be concerned about, though, is with even roots, make sure that your radicand is non-negative. That is, it's 0 or positive. But as an example, remember the square root of -4 isn't a real number. And that's why we've included this idea here. So now, why is it working? Well, if we have an index and an exponent that match, remember you can think of the root in terms of rational exponents. And then by the power property, we can multiply our exponents, and 1/4 times 4 is 1. And the important idea is you can replace a base of x with an exponent of 1 with simply the base. I'll do this first one. I'm trying to undo a square root. Remember there's a 2 here when we don't see the index. And to undo square root, I'm going to square. If I square the square root, this can just get replaced with x. And of course, 3 squared is 9. Of course, we now want to check our answer, so we go to the original, we substitute 9 for x, we simplify, our values do match, and so 9 is our solution. Try this one. Since I'm trying to solve a cube root, which has an index of 3, I'll need to use an exponent of 3, and by the property of equality, I'll need to write both of these as a base with an exponent of 3. On the right, if I cube a cube root, I simply get to my variable of k. On the left, I have to multiply 8 to itself 3 times, which is 512. Again, to check your work, return to the original, substitute 512, find the cube root, and it turns out to be 8. How about here? Since the index is a 4, I'm going to use both expressions as a base for an exponent of 4. These are inverse operations. If I start with y, find the 4th root, and then find the 4th power, I'll be right back at y again. And if I multiply 6 to itself 4 times, I get 1,296. Of course, I always want to return to the original to check my work. Now, one thing you'll find, a lot of calculators won't have a 4th root key. In cases like that, it's really helpful to know that you can write roots as rational exponents, because even if they don't have a 4th root key, if you use an exponent of 1/4 instead, that is, if you put in 1296, hit your exponent key, open a parenthesis, put in 1 divided by 4, and close the parenthesis. That way the calculator knows that the exponent is 1/4. Then the calculator will return 6. How about here? Since the index is a 3, I want the exponent to be a 3. On the left, it'll simplify to x. On the right, I'll get the value -1/1000. And as always, please check your work. Well, that will conclude this video where we've began solving equations that involve roots.